Let's discuss this question in front of us next. The question says x square yz, y square zx, z square xy is equal to x minus y minus z is z minus x times xy plus yz plus zx. Now this is an interesting variety, and let's see how we'll be approaching this question. We'll begin with the LHS, and in the LHS what do we have? Do we have any ones as we had in the previous few questions? No, we do not have any ones which can be converted into zeros easily. No, we do not have any of those things. What else? What else? You have x square yz, then you have y square zx, and you have z square xy. Okay. So the first row is xyz, then you have x square y square zx, z square. You have yz, zx, xy. You seem. Can you please observe that there is a x missing, y missing, and z missing? If you give x, y, and z to these elements, then you will get xyz, xyz over here, right? Similar terms over here, and then it will be possible to subtract, maybe create some zeros, right? So let's do that. What are we wanting to do? We simply want to multiply this by x. We want to introduce x over here. So let's multiply this with x. Let's multiply this with y. Let's multiply this with z. Okay. So we are multiplying the determinant by the product xyz. Yes, we are multiplying the product xyz. We'll divide with xyz as well. What we'll get is x square x power 3 xy z. Then you have y square y power 3 xyz. Z square z power 3 xy z. This is what we have, right, in the product over here. Observe that in the column 3, in the third column, you have xyz. You can take out xyz common from here, and that will come over here, and this will get cancelled with this xyz in the denominator. Yes. So this will be equal to xyz over xyz times x square x power 3 y square y power 3 z square z power 3, and then you have a 1 1 1 over here. This is what you have, right? This will get cancelled, right? And since we have created 1 1 1 over here, now the question becomes very simple. What are we supposed to do? We're supposed to subtract and create some zeros. Let's subtract. R1 can be replaced by R1 minus R2, and R2 can be replaced by R2 minus R3. And what will this give us? Let's take a look at this. This will be equal to x square minus y square. Okay. X power 3 minus y power 3 and a 0 over here. Then you have y square minus z square. Y power 3 minus z power 3 and a 0, since R2 minus R3. And R3 will remain as it is, z square z power 3, and this remains as it is. This remains as it is. This is what you get. Next, once you have reached this stage, can you observe that you can take out something common from the first row? X square minus y square has a factor of x minus y. X cube minus y cube also has a factor of x minus y. And 0 also has a factor of x minus y. Similarly, in the second row, you have y minus z and y minus z. The factors will come out common. What will remain is x minus y minus z times the determinant. This. Observe the determinant carefully. X plus y will remain over here. Y plus z will remain over here. And this is z square. That will remain as it is. Then you have x minus y, since it has gone out, the remaining factor will be x square plus xy plus y square. Here you will have y square plus yz plus z square. Here you will have z power 3, 0, 0 and 1. That remains as it is, yes. What else? Now, what next can be done over here? One thing is, we can expand along this column and multiply these two and subtract them. But if you may observe, this is 2 times 3, which is actually 6 terms, and then you have subtraction also. In subtraction also, you'll have 6 terms. Obviously, some terms will get cancelled, but that will still be very long, yes. So, can we simplify it further? Yes, I can apply one more idea. What is that? Let's subtract these two, and the y square will get cancelled, the y will get cancelled, and yes, we will be getting something easier. So R2 can be replaced with R2 minus R1. Now why did you do R2 minus R1? Why not R1 minus R2? We could have done that as well. But then if you observe, the term that we will get on R2 minus R1, doing R2 minus R1 is Z minus X. And that's something which we are interested in, right? So let's use that. On applying this, you have x minus y is already there, y minus z is also there. Next, the first row remains as it is. This is x plus y, and this is x square plus xy plus y square. This is a 0. The second row is modified now. What is the second row? What happens to the second row? Second row becomes y plus z minus y minus x, which is z minus x. Okay. This y square and this y square will get cancelled. Y square plus yz plus z square. This is it. And what you get is yz plus z square minus x square minus xy. There is a 0 over here. 0 minus 0 is still 0. The third row remains as it is. This is z square, z power 3 and 1. Is that okay? Yes. Observe carefully. This particular term can be further simplified. Z square minus x square, and if you observe yz minus xy, you can take out a yz minus xy, you can take out a y common, you get a z minus x. You also have a z minus x, z plus x over there, you can take out a z minus x common. Yes, and there's a z minus x common over here. So what you will get after taking out this? Z minus x common is this determinant. Let's focus on this properly now. This is x plus y. Okay. This is x square plus xy plus y square, and there's a 0 over here. This becomes 1 since z minus x has been brought out. Then you have yz minus xy. What you observe is y times z minus x was there, y will remain, and z minus x has gone. This is z square minus x square, z minus x has gone, this will remain z plus x. X plus z, you can write it as this. The last term will be 0 only, and z square, z power 3, 1. That's what you'll have over here. Okay, what else? What else? Now, if you observe that expansion along this column becomes very simple. This times this minus this. That becomes simpler, and we can do that. Let's see where does that take us. Over here. Let me erase this one. Okay, and once I erase this one, a few more steps remain. Few more steps? Yes, a few steps. That's one step of simplification actually remains. And what is that step of simplification? This gives me LHS is equal to x minus y times y minus z times z minus x, something that I've already obtained in the product. Other than that, what I'll get is expansion along this column will give me this times this minus this. Okay, that will be a bigger bracket, and you have x plus y times x plus y plus z minus 1 times this bracket, x square plus xy plus y square. This is what you'll have. Is that okay? Yes. So x minus y is done. Okay, y minus z is done. Z minus x is done. And in the product you have, let's multiply them together, x square plus xy plus xz. Observe, this is what you have. X times x is x square, xy, xz. Then you have yx plus y square plus yz. And minus x square minus xy minus y square is what you have over here. Let's cancel the terms that can be cancelled. X square goes with x square and y square goes with y square. This is minus xy and this is plus xy. They will get cancelled, and the terms that will remain is x minus y is okay. Y minus z, z minus x times another bracket. What will that bracket have? xy, xz and yz. So this is xy plus yz plus xz can be written as zx. And yes, this is the RHS of this expression. This is the RHS of this expression. That's the final result. That's what you obtain. Is that okay? Yes. One particular thing that I would like to bring to your notice is that this is also important circulant. You call it important circulant. X square yz, y square z square, z square xy. But this is, I don't want you to remember in this form. This RHS is also equal to, can you please observe that in the middle we had this determinant. At one stage we reached this determinant. And do I want to remember this one directly? No. I want to remember it in another form. What is that? I want you to remember in this form that 1x square x power 3, 1y square y power 3, 1z square z power 3, this determinant is equal to this value. Oh, where did you get that from? What I've done is I've simply interchanged these two ones. So 1 will come over here, x square will go over there. But the value of determinant will be changed by a negative, change in sign only. Then I make another interchange of x square and x power 3 and I get this. Okay, so another minus introduced will give me the same determinant. So this and this are exactly same and therefore the proof, right? So 1 x square x power 3, 1 y square y power 3 and 1 z square z power 3 is equal to x minus y, y minus z, z minus x times xy plus yz plus zx, right? This is something which you can memorize.